afternoon, everyone. I am Vijay Krishna, Assistant Professor in Department of Mechanical Engineering in Institute of Aeronautical Engineering. Today, we will discuss the unit module 4, that is nothing but corrosion of engineering tribology subject. Okay, let's see what the contents we are going to be discussed in today's class. These are the contents we will going to be discussed in today's class. First one, we will try to have the introduction to corrosion, and secondly, we will have the what are the effects of corrosion, and we will also see what are the causes for corrosion and simple theories of corrosion, and types of oxidation corrosion and corrosion by other gases, and the difference between dry and wet corrosion, and the types of electrochemical corrosion and factors influencing the corrosion. And finally, we will see how to see the corrosion control. Okay, we will discuss all these categories one by one in depth. First, we will try to see what is corrosion. Now, introduction to corrosion. Corrosion is undesirable process. Due to the corrosion, limitation of progress in many areas is occurring. The cost of replacement of materials and equipment lost through the corrosion is unlimited. Okay. See here, corrosion is nothing but a undesirable property, because any metal or material gets corroded, and because of that reason, you will be have the limitation of progress. For example, if we are considering a boiler, steam boiler in an cooking vessels or anywhere, if it is corroded, then it has to be replaced with a new boiler, because corrosion will make the food effective or poisonous. There is a chance of making the food contaminated. So in such cases, we, instead of repairing the steam boilers, we will be has to be what we call replace the new boiler. Because of that reason, whatever the progress of the steam boiler will be are limited, or obstructions will be occurring. Okay, replacing a corroded material is very costly process. So because of that reason, generally metals and alloys are used as a fabrication and construction materials in engineering. Okay, because of corrosion native, most of the metals and alloys are used as a fabrication or construction material in engineering. If the metals and alloy structures are not properly maintained, they get a deterioration process. That is nothing but slow action of deformation. This deterioration or deformation take place due to the slow action of atmospheric gases, moisture, and other chemicals. Okay, this phenomena of destruction of metals and alloys is known as a corrosion. Okay, in simple, corrosion is nothing but deterioration or destruction of a metal and alloy is known as a corrosion, and the corrosion occurs because of the atmospheric gases, moisture, and other chemicals. Corrosion of a metal is defined as a spontaneous destruction of metals in the course of chemical, electrochemical, and biochemical interaction with the environment. Thus, corrosion is exactly reverse of extraction of metal from ores. Okay. In general, corrosion is defined as a destruction of material because of the chemical, electrochemical, and biochemical interactions with the environment. Okay. Example, rusting of an iron is an example corrosion. In rusting of iron, a layer of reddish scale and the powder of oxide is formed on the surface of iron metal. Whereas in copper metals, green film of basic carbonate is formed on the surface of copper when it is exposed to the most air containing carbon dioxide. Now we will see what are the effects of corrosion. Now we will try to see what are the effects of corrosion. The socio and economical consequence of corrosion includes The socio and economical means in the terms of the replacement cost, all those will be occurring, and the social consequences are nothing but the damage of the material will disturb the what we'll call the work process, and even the suppose if you are having the cladding at your building, if a corrosion take place, then removing of such material is costly process, and it also give the aesthetic deformation. So it will, all those will comes under socio consequences of corrosion. We will try to say first one. Due to the deformation of corrosion product over the machinery, the efficiency of the machine gets failure, leads to the plant shutdown. Okay. See, if the due to the corroded product, there is a chance of reducing the machine. Okay, if the machine is got corroded, then the performance of the machine will be slowed down. Because of that reason, it is efficiency decreases. So if the machine efficiency of a machine decreases, then there is a chance of a reducing the production of the products in the industry, which also may lead to the shutdown of the product. Second one, we will try to see the products contamination or loss of products due to the corrosion. Okay, generally, if it is a what we will call food industry or baking industries or otherwise beverages industry, there we will be using the machines for mixing of the fluids, baking of the fluid material, all those. In such cases, if we are using the corroded product, then there is a chance of food contamination and leads to the food poison also, because of these reasons, because of the corrosion. So these are the effects of some of the corrosion in food industries. Also, it plays a major role. Third one, we will try to see corroded equipment must be replaced. Okay, we can't continue with the corroded equipment or corroded product. We have to replace it with immediately, otherwise it may lead to the what we'll call contamination of the food, spoiling of the machinery, and decreasing the efficiency of the machine, like that. Okay, fourth one, preventive maintenance like metallic coating or inorganic coating are required. Okay, in some cases we can avoid the corrosion process by a coating, giving the metallic coatings like organic and inorganic coatings. We can avoid the corrosion. Next point, corrosion releases toxic products. Okay, any machinery or any product, equipment, if it is got corroded, not only it the spoil the machinery, it will also give the toxic products. It's this will be very serious consideration to be considered in the food industries or beverages industries or baking industry. If we are using the corrosive utensils, then it may contaminate the food, which may lead to the food poison of the people also. Okay, to avoid that one, we have to give the necessary coatings, or otherwise we have to remove immediately. And the sixth point is nothing but health from the pollution due to the corrosion product or due to escaping chemical from corroding equipment. Same as I explained earlier sentence, corrosion releases the toxic products. Because of toxic in nature in the products, or if it is in food industry, then the health of the persons may be damaged, like food poison may occur. Okay, giddiness may occur. Like this, it will have the what we'll call issues related to the health if we are using the corroded product in the food industries. Okay, now we will try to see what are the causes of the corrosion. Causes of the corrosion is nothing but in nature, metal occur in two different from native state and the combined state. In general, a classification of the metals or metals will occur in two forms: native state and the combined state. Native state is nothing but metal exists as such in the earth crust, then the metals are present in the native state. Okay, native state means free of uncombined state. The metals are non-reactive in nature, and they are noble metal which are very good corrosion resistant. Example, AU nothing but Aram we will call, that is nothing but gold, and peat is platinum, and Ag is nothing but silver, etc. All these are native state material. Native state materials are nothing but, in simple, the material which are available directly from the earth crust or earth core, which are not the combination of different material. They are non-reactive in nature. Non-reactive in nature means they will not combine with the other materials. Okay, they are noble material which have the very good corrosion resistance. Okay, now we will try to see the combined sand. Except the noble material, all other materials are highly reactive in nature, which undergo the reaction with the environment to form the stable compounds called as ores and minerals. Okay, this is the combined state of metals. Example: iron oxide, zinc oxide, plumber sulfate, calcium carbonate, etc. All these are nothing but combined states. Combined state is nothing but some material will not be function properly without the combination or addition of other components or other metals in that one. Such type of material which are work only in association with other metals we will call as a combined state. Such type of metals are highly reactive in nature. The examples of combined state material, as we have seen here: iron oxide, iron trioxide, zinc oxide, calcium carbonate, etc. Next, we will try to see what is metallic corrosion. The metals extracted from their metallic compounds. During the extraction, ores are reduced to the metallic states by applying the energy in the form of various processes. In pure metallic state, the metals are unstable as they are considered in excited state. Therefore, as soon as the metals are extracted from their ores, the reverse process begins. Begins and form the metallic component, which are thermodynamically stable. Hence, when metals are used in various forms, they are exposed to the environment. Then, exposed metal surface begin to decay. This is the basic reason for metallic corrosion. Okay. In simple, we will try to see what is metallic corrosion. Generally, metals are extracted from metal compounds we will call as ores. Okay. Metals are extracted from the metal ores. During the metal extraction process, ores are reduced to the metals in the presence of various processes which are stable at the temperature. But after products are used, then they are used at very different temperatures. During that time, corrosion of the metals will take place. Such metals is called, because of uneven working of the metals at the different temperature, are called as the it is a reason for the metallic corrosion. In simple, what we are saying, metal corrosion take place because of the working of the metals at the different temperature in which they are extracted. Okay, that is we will call as a simple metallic corrosion. Metal is nothing but when you get corrosion oxidation, then leads to the metal compound plus energy. When we will reverse this product, then we will call as a metallic reduction, and the metal will be removing. Although the corroded material is thermodynamically more stable than pure metal, but due to corrosion, useful properties of metal like malleability, ductility, hardness, luster, and electrical conductivity are lost. Okay. In general, corroded material is more stable than what we will call the pure material. But because some properties such as malleability, ductility, hardness, luster, and electrical conductivity are lost. Because of that reason, we will remove the corroded material from the what we will call the equipment or machinery or anywhere. Now we will try to see the sub-theories of corrosion. Generally, based on the environment, corrosion is classified as dry corrosion or chemical corrosion. Dry corrosion or chemical corrosion. Wet corrosion or electrochemical corrosion. Okay. In simple, you will be having two types of corrosion: dry corrosion or chemical corrosion, wet corrosion or electrochemical corrosion. We will see one by one. Okay, first we will try to discuss about the dry or chemical corrosion. In simple, for understanding, we will try to use the terms what we will call dry corrosion and wet corrosion. Okay, now we will try to see what we call dry corrosion. This type of corrosion is due to the direct chemical attack of metal surfaces by the atmospheric gases such as oxygen, halogen, hydrogen sulfide, sulfur dioxide, nitrogen, and the hydrous inorganic liquid. Okay, the chemical corrosion is defined as direct chemical attack of metal by atmospheric gases present in the environment. The examples of dry corrosion is nothing but silver materials undergoing chemical corrosion by atmospheric hydrogen sulfide gas, whereas iron metal undergoes chemical corrosion by HCl gas. Okay. In simple, dry corrosion or chemical corrosion is nothing but the corrosion in which corrosion take place due to the attack of metallic atmospheric gases. Okay, the attack of atmospheric gases on the metal surface we will call as a dry corrosion. The examples of dry corrosion are silver material which is get corroded because of hydrogen sulfide present in the atmosphere, whereas iron material which get corroded by the HCl gas present in the atmosphere. We will try to see the types of dry or chemical corrosion. Okay, types of dry corrosions are corrosion by oxygen, corrosion by hydrogen, and the liquid metal corrosion. There are three types of dry corrosions are there. They are corrosion by oxygen, corrosion by hydrogen, and corrosion by metal corrosion, liquid metal corrosion. We will try to see. Okay. Oxidation corrosion are nothing but corrosion by oxygen. This is the first type in the dry corrosion. We will try to see. Oxidation corrosion is brought about by direct attack of oxygen at low or high temperature on the metal surface in the absence of moisture. Alkali metals and alkali earth metals are rapidly oxidized at low temperature. Okay, at high temperature, almost all metals are oxidized. Okay, well, we will try to see what is the oxidative corrosion process. Oxidative corrosion is nothing but attack of a oxygen. Attack of a oxygen on the metal surface at low temperature and high temperature in the presence of moisture is known as a oxidation corrosion. In simple, oxidation corrosion is nothing but attack of oxygen on the metal surfaces at different temperature, whether it low temperature or high temperature. Okay, alkali metals such as lithium, sodium, and potassium, etc., are alkali metals, and earth metals are rapidly oxidize at low temperature. Alkali metals and the alkali earth metals are get oxidized at the low temperature, and whereas the metals are oxidized at the high temperature. The reaction of oxidation are as follows. You can see the mechanism over here. Oxidation take place at the surface of the metal, forming metal ions M2 plus. You can see the metal, and when it undergoes oxidation, it will be written as the M2 plus ion plus loss of the two electrons. Okay, oxygen is converted to oxide ion due to the transfer of electrons from the metal. Okay, then overall reaction is of oxide ion reacts with the metal ions from metal oxide film. Okay. The nature of the oxide formed plays an important part in oxidation process. Whatever the nature of oxide which is formed plays a major role in oxidation process. You can see here, metal plus oxygen gives metal oxide. It is a metal oxide is nothing but a corrosion product. When oxidation starts, a thin layer of oxide is formed on the metal surface, and the nature of the film decide the further action. Nature of the film decide the further action. Okay, when the metal is exposed to the oxygen, then metal oxide is formed. When metal oxide is formed, oxidation starts a thin layer of oxide is formed on the metal surface, and nature of this film decide the further action. If the film is you can see the oxidation nature here, diagrammatic representation here. You can see electrolytic cell involving the two materials, and here you can see electrolytic cell involving one materials only. Here you will be having the oxidation process, and here you can see the reduction process. At the anode you will be having the oxidation process, and at the cathode process you will be having the reduction process. The electrons will be flow from the anode to cathode. Okay, same way you can see that all these two are blue colors are nothing but electrolyte, and you can see here cathodic area you will be having the division of the hydrogen ions will be there. Okay, you can see the electron reduction. Okay, oxidation is nothing but anodic reaction, and the reduction is nothing but cathodic reaction. Okay, you can see the here, if the film is stable, if the film is then in oxidation corrosion only, stable layer, unstable oxide layer, and volatile oxide layer and porous oxide layer will be there. Okay, we will try to see what are the different types of layers are there in the oxidative corrosion. Okay, first we will try to see what is the stable layer. A stable layer is a fine grained in structure and can get adhered tightly to the parent metal surface. Okay, stable layer is nothing but a fine grain in structure that can be stick to the parent material easily. Hence, such layer can be impervious in nature. These stable layers are impervious in nature. Such a film behaves as protective coat in nature, thereby shielding the metal surface. The oxide films of aluminium, plumbum, cuprum, and PT, etc., are stable, tightly adhering, and improves in nature. Generally, stable layer is nothing but the fine grain structure which can be applied on the metal surfaces, and it acts as a film. It acts as a film, and it protect from the nature, thereby shielding the metal surface. The examples of the day-to-day life of automobiles, we will be having the Teflon coating. Here, fine grain material are coated on the automobile, so it form as a film, and it will shield from the metal surface getting corroded. Okay. Generally, the oxide films of aluminium, cuprum, all these materials are stable and tightly adhere and impressive in nature. Impressive is nothing but it will not create any effect on the parent material or base material. It will slightly adhere. Adhere is nothing but it will stick to the parent material, and it will protect from corrosion. Okay. Next, unstable oxide layer. Unstable oxide layer. This is formed on the surface of the noble metal such as Ag, Aram, Pt, and as the metallic state is more stable than the oxide, it decomposes back into the metal and oxygen. Hence, oxidation corrosion is not possible with noble metals. Okay. Unstable oxide layer, this formed on the surface of noble materials. Okay, metallic state is more stable than oxide layer. Because of that reason, metal and oxygen is decomposes, hence the oxidation corrosion is not possible with the noble materials. Noble materials oxidation process will not take place. Next, we will try to see volatile oxide layer. Volatile oxide layer. The oxide layer forms, the oxide layer film volatilizes as soon as it is formed. Hence, always fresh metal surface is available for the further attack. This causes continuous corrosion. Molybdenum trioxide is volatile in nature. Okay, in simple, volatile oxide layer volatiles as soon as it is formed. Okay, the name itself indicates volatile is nothing but unstable material, or whenever it placed on the metal surfaces, it immediately volatilizes or escapes from the metal surfaces. Such surfaces are always form the fresh metal surface is available for further attack. Nothing but volatile is nothing but if we are spraying the coating on the material surface, it will immediately escapes from the metal surface. In such cases, there is a more chances of causing of corrosion. So there is every time there is a further chance for attack on that one. This causes the continuous correction process will take place. Molybdenum trioxide is a volatile in nature. Okay. Porous layer. The layer having the pores or cracks. In such cases, the atmospheric oxygen have the access to underlying surface of the metal through the pores and cracks of the layer. Thereby, the corrosion continuously unobstructed till the entire metal is completely converted into oxide. Porous material, porous layer or porous is nothing but porous material will have the holes or cracks in the material surface. If there are holes and cracks are there, there is a chance of atmospheric oxygen entering into the metal surface through pores, holes and the cracks, and which will lead to the corrosion process. In these cases, corrosion is a continuous process, and the corrosion occur till entire material is get corroded. Okay. Okay, we will try to have the next. There is a one rule called pilling Bedworth rule. Generally, it is used in that one. Pilling Bedworth rule. Here, pilling Bedworth rule is nothing but according to this rule, an oxide is a protective or non-porous. Oxide is a protective or non-porous if the volume of oxide is at least as great as volume of the metal from which it is formed. Okay. Simple saying of this rule is nothing but according to the rule, whatever the volume of oxide should be equal to the volume of the metal from which it is formed. Okay. On the other hand, if the volume of oxide is less than the volume of metal, the oxide layer is porous. Okay. If the volume of oxide is less than the volume of the metal, then the oxide layer is porous. Hence non-protective because it cannot prevent the excess of oxygen to be fresh metal surface below. Okay. Thus, the alkali and alkali earth metals like you can see Li, potassium, sodium, and the magnesium form the oxide of volume less than the volume of metal surface. Whatever the metals we are seeing here, these metals oxides will be less than the volume of the metal. Consequently, oxide layer faces the stress and strain, thereby developing the cracks and pores in its structure. Okay. Porous oxide scale permits oxygen, free access of oxygen to the underlying metal surface for fresh action. Thus, corrosion continues non-stop. In simple, filling Bedworth rule is nothing but the volume of the oxide should be less than the volume of the metal surface. If the volume is less than at least what according to this rule what is saying, the volume of oxide should be at least as great as the volume of metal from which it is formed. Okay, it should be greater than. volume of oxide should be greater than the volume of the material. If the volume of oxide is less than the volume of material, then the metal will be porous in nature. If the material surface is porous in nature, pores or holes or cracks are formed in the metal surfaces. When the cracks or holes are formed in the metal surface, there is a more chance of access of oxygen to enter into the metal surfaces. When oxygen is enter into the metal surface, oxidation process will take place, and because of oxidation, there will be forming the metal oxide. Metal oxide is nothing but corrosion process. Okay, here we will try to stop here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.